Hello and welcome to episode 41 of Cooking with Unity. I'm your host, Maximilian Moreau, and with me is my tech, Philip Wilson.
Uh-huh.
All right. All right. So this episode, we are going to do just a one-off. We're going to play around with shaders, and I think that's actually what I'm going to title the episode, Playing Around with Shaders, because I've been messing around with this program called Strumpy Shader Editor. You may or may not have heard of it, but it's a visual editor to create Vertex programs or shaders for Unity. And so I'm going to just hit play here. This is just something I was playing around with. So the ground here, and actually the sky, is these are two shaders I wrote. This one is a world map spaced shader. So like I'm moving through the world right now. You can see the Z changing, but if I was to stop moving, you can see that the grid is what moves. Like I'm actually moving in the scene here. When I hit move, it's actually the whole thing kind of following it. We did something similar to this.
It's like a magic carpet.
Yeah, we did something similar to this actually in the side-scrolling platformer thing, where we had it set up so that the texture would move. This one's doing it in a shader as opposed to doing it on the CPU, which is probably better for it. Also, it's a screen space gradient shader, so you can see when it's near the top of the screen, it's blue, but if I move it, if I pan, which is hard for me to do without a mouse, you can see it becomes darker and towards the bottom of the screen.
That's cool.
So,
you should call this episode Shaderlicious.
Shaderlicious. I will consider that.
Okay.
I like that. So this is just me messing around with stuff. I'm just gonna open the editor so that you can see what it looks like, but we're gonna start fresh when we actually start working here. So this is a massive mess of wires right here, and some of them I'm not even using. This is something I was experimenting with when I was trying to get the cube mapping portion of my shader to work. I probably don't know enough about shaders and theory to actually teach this stuff, but I think that's the importance of this, because I had a lot of fun just downloading this and playing with it, and you can get some really interesting effects just by making mistakes in this little system. So
that's a good
so thing. Let's so the whole point here is so bear with me. I don't know what I'm doing, but we're going to play with it, and we're going to see if we can create some cool effects. And I'm going to kind of walk us through what each of these things mean. And we'll probably do an episode later that kind of goes more into this on the actual code side, because what this is doing is this generates CG code, which is a type of programming language for shaders. There's two major ones. There's there's CG and there's GLSL. And if we focus on the show, it'll probably be CG. I may point out other tutorials on there that have already covered this better than me anyway. But what we're going to be focusing with today is this editor here, this Strumpy Shader Editor. So
it's interesting, as you were trying to show me this earlier. I'm like, no, show me it on the show, because I don't know anything about this.
Yeah, exactly. So all of Phil's questions are going to be 100% legitimate questions on this show. And a lot of them I'm going to probably say, I actually don't know.
Oh, okay, cool.
And it's okay to say that. Remember, it's okay to not know something, because that just means it's one more thing that you get to learn. So I didn't need to quit on that, but luckily it goes up fast enough. So we're going to create a new project. Documents. Cooking with Unity.
41. I don't know whatever today is.
I like the date.
2/11/2013.
All right, there we go. Got to translate that into the
year, month, day.
Yeah, because I like it to sort nicely on my computer. All right, so here we are. We're on a fresh project. Nothing special. So what we're going to first do is we're going to go to the asset store, and I'm skipping the logging process here, so we don't have to worry about that. And I'm just going to search for Strumpy Shader, and that should probably be enough for us to get. All right, there we go. 5 stars. This is free. This is another reason why I went for it. So you guys will probably see free here. I've already bought it, quote unquote.
Price free right there.
So yeah, price free, but it'll also say it here. Just click it, do whatever it wants you to do, log in, whatever, and then hit import, and it should download and import into your project. There we go. And so when this screen comes up, just say import. Yours will have to download, obviously, though I don't think it's a huge download. All right, so and then we have Strumpy Shader Editor. So when we come back in here, I'm just gonna hit play and then not play. That wasn't enough, evidently. Oh, there we go. Okay, as soon as I clicked a window, the menu bar here has to refresh. So here's a shader editor thing.
Oh, and you
they
can
really probably
donate
should have
if you
put it
want
into
to.
window here. Yeah, you can donate, and if you like this, you should
should.
donate. I'm probably going to do it once I actually have money. Right now, I'm a little bit weak on cash to donate for anything. So if you hit Start Share Editor, you'll come in here, and it will actually already be filled in with something. And I think this is their rim shader. I think. Yeah, this is their rim lighting shader. I'm actually going to show you this one because this is a really cool looking one.
I'd like to see this as well.
So first off, this is technically, it's red right to left, basically. This is your output here. This is the final result of your pixel.
Oh, well, I was doing it all wrong the whole time.
And so the inputs come from the right and then go to the output. So in this case, it's taking the view direction information. It's taking a variable that you can feed into it. It's using an exponent for this. This is a power function. This is the equivalent of just taking, in code, you would just be
two
like...
arguments.
Yeah, you take the argument 1, and then you put it to the power of the argument 2. Same thing here. This is just a multiply. This is just a function pipeline, basically. And then this is a property that you can edit in the editor. This is another property you edit in the editor, and then it has another property and another property. So the only thing that's actually real-time, not a property value in here is the view direction. And it's used to it's a pretty awesome effect, actually. So let's just try and get this one working. So you'll see here you have a load, save as, export as. So you can go ahead and save this one if you want to, but I'm going to show you which one it is. If you go to load, this shader is the rim lighting S-graph. If I just hit that open, it'll bring it back to where it was.
Rim lighting.
Rim lighting, yep.
Like custom rims?
So yeah, like custom rims. It's actually a edge lighting technique. You'll see what it does in a second.
I see. I understand.
Yeah. So
I was just trying to make it funny.
So we do export as. So when you save it, it's just saving this graph information. This is not actually the shader itself. You have to export the shader to get it. So when you do export as, it'll bring up this menu. It'll say shader, and we're not going to be that lazy. I'm going to call it rim lighting. IGHTING.
That seems appropriate.
And I'm just going to put it in the assets. So you hit save, and it'll stay graded for a second while it compiles it, and you're done. So what this is actually generating is it generates real shader code. I'm going to look at it here now. I'm not going to go over everything that's going on here. And you can see that it's not very well organized visually because this is all programmatically generated. It's good enough for the compiler. They don't care how it looks to the people.
You could discern this if you had the time. But...
the other thing that you'll probably notice is if you have experience with shaders, it's not 100% efficient. There are places where we could probably get the variables much nicer if you were doing it just in code yourself. But as neither of us know CG right now, we're just going to leave this be. But this does generate here, so you can learn a little bit about CG from just looking at the output. Mm-hmm. And then this is actually compiled by Unity into the actual bytecode shader for whatever platform you're on. I did not mean to close that window. Okay, whatever. So we have this rim lighting shader. So how do we use it? So if we go into, let's create a sphere.
Oh, spheres are always good.
It's really good for rim lighting too. I'm going to move this down here.
I find that interesting.
And we're going to move this to 0, 0, 0. I'm going to refocus on it. Actually, I'm going to align view to selected for the main camera just so we know what it's looking like. All right, and then we're going to just bring this sphere a little bit closer.
Whoa.
So here's the sphere with just a standard diffuse shader. And actually, let's put a light in the scene. So,
it's really not that exciting with the standard diffuse shader, is
it? Not exciting. Although there was a time when this was actually very exciting.
No, I agree.
Like this is one of those things where it's just like it doesn't look like much, but there's a lot going on even there. So here we go. So now we're going to put our other shader on. So the shader we can't just drag on to. Actually, maybe we can. Let's find.
Oh, you could.
Nope, you can't.
No.
Didn't think so. You have to actually create a material for it. So if you select the shader before you choose create material, it will actually automatically create a material that has the shader.
Oh, that's cool.
And it names it properly. If you didn't want to do it that way, when you add a shader, it automatically shows up in this list when it's in your project. And I can show you how to put it into the submenus too. You can create your own submenus as well.
That's cool. We should do that.
Yes, it's very easy to do actually. I'm probably going to eat my words on that in a second here. So you can see already this is really cool. Yeah, so I'm going to drag it in there. So here's what a rim lighting shader is. So So this creates, so we have this rim color here, and you can change basically the outside rim of the shader.
That is really cool.
And it still otherwise activates. It otherwise is basically a specular shader. So with the directional light affects the shading of it, but then it additionally has this eerie glow on the outside rim.
Oh, that's cool.
And it's really cool looking. This is the kind of thing that you would want for like a planetary shader. Any good planetary shader will have a rim component so that you have the like halo around it for when you backlight things. So
it's really cool.
So yeah. So that's a cool shader. And it's actually pretty small. It's actually much less complex than the first one I showed you, even though mine's stupid. Just ignore my stuff because as I said, I just was playing around with it. But so let's go over what's going on here. So the simplest stuff, we'll start with the three simplest parts first. So color, diffuse color. This is, I'm going to put this into a, going to try and put this on another screen. Come on, Mac OS, work with me here.
There it goes.
That was the wrong window.
Yes, it was.
But it wants to... All right.
There you go.
Crisis averted. All right. So now we can go between them quickly. So diffuse color here corresponds to the diffuse color input here. So that's just the color. And so diffuse, this is also known as albedo. I may be pronouncing that incorrectly. And actually in the shader editor, in Strumpy shader editor, and actually still in his documentation, it's still called that. He changed it recently, and I assume it's because of the confusion regarding that. People really see diffuse a lot for describing lighting, and they see albedo very little, and they're basically the same thing. I'm probably going to get an email about that one at some point, but but they're basically the same thing. And so he decided to change it for just to be more consistent with the terminology that they use in Unity. I believe that if we were to look at the shader here, it'll say albedo. See, it says diffuse color there, but where does it actually put it in?
There it is.
There it is, yeah. That's it right there.
Albedo.
Yep.
It's
or
like
albedo
Albert's
or
libido.
something. Yeah, something like that.
Albedo.
So this one's just a color, and it's just sending the color to the output. So whatever that color is will be the output. Now, aside from lighting. And lighting, does this have a lighting graph? So there's three different graphs. There's pixel, vertex, and lighting. We're going to talk about pixel a lot. We're going to talk about vertex a little bit. And we're not going to talk about lighting at all because I haven't figured it out at all.
Okay.
We might make an experiment with it. But,
is there a lighting map right now? No, there's just...
So lighting. There's not. So if you don't fill these in, I think it automatically fills in some defaults for you, although I'm pretty sure like if you don't fill in gloss and specular, you don't get either of them. Diffuse, let's actually test this. So if I disconnect the diffuse... Oh, wait, it needs a color of some kind. I don't know. Actually, let's see if we can screw up the lighting real quick, just for fun. I'm just going to put constant 1 and pipe it to lighting and see what that does. Out of curiosity. So I'm just going to save, and then I'm going to export.
And it exports to the same shader?
Yeah. Okay, so now it's really, really lit.
Yeah, now it's constantly 1. Yeah, it's constantly all lights in the world.
Way. Let's try 0. Let's actually replace this with a constant 0. Bam. You can just leave things hanging there. It won't complain or anything. It just will ignore those.
And it won't even export them in the code?
Nope. All right, so now it's completely dark. So now it doesn't matter where our light is.
It's constantly
dark. So that's kind of how it works on that one. So it's probably...
Could you do a lighting of like between 1 and 0?
Yes,
basically
we can.
Having it arranged?
So there's these constants, 1 over pi. They have a few ones that are just useful. Pi, 1, 0, 1 over pi. I don't know what luminance is. But you can also do float const, which this one allows you to just change the value here to whatever you want. So if you wanted 0.5, you could put 0.5. Throw it into the lighting master, save, export. You go back in, and there it is.
So it's like, wow, it seems like that's just the lighting for everything.
Yep, that's every, I'm not going to say per pixel because I'm not even sure on the lighting side of things. It probably is, but I didn't really know there was a separate pipeline for it. So there you go.
Know now.
Yep, now I know. So let's go over this. So this is just a color. And what this is, what this represents, what this output represents is on the pixel pipeline, which is what we're on the pixel graph. This determines this takes in a bunch of pixels and it outputs a color. That's effectively what the diffuse portion of this does. It just outputs a color. And that color can be modified by the lighting graph separately, but by itself is actually just outputting the color. The lighting is a separate pass, I'm assuming. So so what this means is this is what happens to every pixel. So the first pixel comes in, and it's like, what color should I be? And it comes here, and it's like, oh, I should be, what do we have it set to? I should be red. And every pixel that comes through this, it asks this thing the same question. This diffuse is like, what color am I today? Red. And then it goes to the next pixel. It's like, what color am I today? Red. And it goes to the next pixel. What color am I today? Red. And it does that for every single pixel that is being rendered for the object. I wasn't going to say the whole screen because in this case it's just the area on the sphere.
Object.
But for every pixel within that sphere,
should update that thing so it's not just.
All right, fine. Did I already delete the?
Yeah.
Okay, so I'll just hit save, make it look pretty again, export.
Yeah, it doesn't look nearly as cool with that. There we are.
All right, there we go.
Yeah,
So
it looks so much.
looks so good. Well, that's because we actually get like all this specular stuff, which that's the other thing that I'm a little confused by, because I would have thought that like gloss and specular is more of a lighting pass type thing, but maybe it's not. And again, I'm probably going to get emails from people that's like, why are you doing this show when you have no idea what you're doing? And that's the point, actually, is I want to show how you can play with things even if you don't know how they work. You can learn from this. So I mean, like, all I know from this is the few days I've been messing around with it, and I got some things going on.
Yeah. I mean, that's how anyone learns anything.
Same thing here with gloss. It's a single thing here. Every time that that asks what gloss a pixel should have, this thing returns whatever we said in here. So it's probably, it says a range of 0.1 to 1, so it's probably 0.4 something, 0.45 or something.
Yeah.
Specular color, same deal. Always the same color. What color am I? This color. So here's the only one that's doing anything interesting. So the one that's doing something interesting is it's taking the view direction, and then it's doing a Frensel function on it. And actually, they were nice enough to actually show what this function is in the comments. So you can actually create a comment and it shows underneath here. So Frensel is 1 minus the dot product of the view and the normal of the pixel, I guess. I guess I would probably be based on the vertex normal. Oh, wait, no. You can feed in a normal. So I don't know what it uses by default. All right, well, anyway, all it's doing here, basically, is it's getting information about the view direction. It's moving it to a power. Why can't I click on anything and drag it around now? Is it running still? Okay. All right. This editor sometimes has a few little problems. It may just be on the Mac side, so if you're on PC, you can laugh about that.
Hey, it's free.
It is free. Yes, it's totally free. And actually, as I said, I'll probably run into some problems on the show. Either moving out from the window or closing the window and reopening it solves every issue I've had with it so far. So just one of those things. So it's taking the power of it. So this one will give you a different answer based on what pixel you're talking about. So I'm assuming it's talking about the surface normal here because we're not feeding in a normal. So what will happen here is basically this edge is based entirely on direction of the camera, and that makes sense when you think about it. So like, no matter what angle I'm at, you'll see that the blue is around there.
It's
now
occasionally near the edge.
It occasionally gets blended via the lighting to the other colors, but you can see that it's there. And if we were to make everything really obvious, we could turn the diffuse color to black, and you can see it really clearly there, and we can change the specular color to black. And you'll see that blue is always there, and it's always based on the screen direction. And that's the important thing to take away from this, is they're using the view direction to determine what amount to put into this. And so the rim color here isn't being multiplied, and it's being put into this thing called emission. So what emission is this is actually a pseudo lighting type thing, and it goes on top of the shader. And we could probably get a very similar effect to actually add it into the diffuse. And actually, I'm gonna show how we would do that real quick. So let's try not using emission and try adding it to the diffuse and seeing how it looks. So the way we can do that is simply by adding an add operation. We're going to do an operation add, we're going to connect in the two arguments. I'm just curious what this is going to do. This is probably going to go over what we actually want, but let's see how this looks. It may look exactly the same, too, for all I know.
Well, let's see.
Export. All right, it does not look exactly the same.
Looks similar.
Similar. But I think it's because it's adding the black together now, so we're getting some... Here, let's see what it looks like with red. Yeah, it's more subtle this way. I don't know exactly what the difference is, but you could go through it either way. It's kind of neat to have this emission thing, and I actually kind of like the way it does. Actually, let's see what that does. Let's do both.
Yeah, sure, why not?
We can. Why not? Let's hit export, see what that does. Bam. Okay, so now it's really bright. It's actually blending differently, too, with that. Let's actually change the specular highlight there. There we go.
That's pretty neat.
Yellow looks good with red for highlights. Yep. All right. So yeah, that's a basic shader. So let's make our own. Let's start playing around with this.
Okay.
Or do you want me to start going over the Vertex shader? What they don't have, I don't think they have a good example of. And here, let's see what their example shaders are. So we've got clip, default lighting. I actually did look at clip because I was trying to do clipping earlier and I failed at it.
What is clip?
Clip is let's see what this actually does.
Clip anything below 0.5. That's what it says.
Subtract, subtract.
No, that's it.
All right, so let's see what it does. Actually, let's find out what we think it's going to do. So, world position, splat, so it takes the world position, just takes the Y channel, or it puts everything on the Y channel. I forget exactly what that does.
I don't know.
Multiplies it in by a range. It's based on world position. Interesting.
A splat would make sense that it would convert everything.
Let's see what it does. Let's see what it actually does. Oh, I didn't want to save. Okay, so we want to export as. We're going to call this one. What was it called? Clip.
Clip, yeah.
I'm just going to call it clip. So this should make it. Basically, what clipping does is this determines whether or not a pixel should be rendered at all. And so this is what. If you've played any modern shooters, you've probably noticed this pattern. The first time I noticed it was in Half-Life 3. I'm not saying that was the first. Not
Half-Life 3.
Sorry, Halo 3.
Halo 3.
I'm not saying that was the first place that it was used, and actually, that's not entirely true. Like, the first place I've seen the concept was in Quake for Stipple Alpha, but it was a very specialized case. But basically, in the distance, you'll see that objects will kind of pixelate out as opposed to fading out in Halo 3, and in a lot of modern games, you'll see this. You'll see it in Call of Duty, you'll see it in almost every modern game. And the reason that you'll see that is, we haven't gone over why, but things can be transparent using alpha, but anything that's transparent using alpha, you don't have to worry about it in Unity. Unity does this for you. This is something you have to worry about when you're writing your own game engine. You have to sort that separately. So you render all of the stuff that's not transparent first, and then you render all the transparent stuff, and it has to be rendered specifically back to front order. Otherwise, it won't work right. It won't look right.
Correct.
And so what's nice about clipping is clipping doesn't matter when it renders because you're not blending to the background pixel. You were just literally either rendering a pixel or not rendering a pixel. And so if you use that instead, all of a sudden, like if you're playing Skyrim, it does this. Skyrim has all that grass that goes out there. I'm not sure if you remember Oblivion. Oblivion actually transparent faded the grass as it went out. That's extremely costly because they have to keep the depth list of everything in there, and they have to do a depth check, and they have to do all this and make sure that all the geometry is sorted to render in that order. And in the new game, they do the stipple thing, and you don't have to worry about it. They're done. They just render it out.
Yeah.
So let's see what this actually ends up doing. I did not mean to do that. So we actually need to create a new material. Oh, that's cool. That's actually very cool.
That's not what I expected at all.
So this is what it does. And actually it's based on world position, so if I scroll this up, it's going to look cool.
That is pretty cool, actually.
Yes. Yes, that is very cool. So
that's much cooler than I thought it was going to be.
So this thing actually cheats in two places, so I'm going to have to point out something else to you. If we were just to open up Strumpy Shader Editor, choose New, and choose Clip, and clip it the exact same way, is not going to look that good. Because there's one setting in particular I'm going to point out here that they're doing here. So in settings, you can do, there's a lot of global settings for this thing. And one of the things that they had to change is cull mode is off. By default, this is set to back.
Okay.
And I'm going to change it to back just so you see what the difference is. It'll still look cool, but it's not nearly as cool. So this is with the back face culling still on. So that's what the culling ratio is. Now, I'm going to show you the before and after again. So there's this one.
Yeah.
And then, did you notice the difference?
No.
Okay. So take a good look. Good look at this
Oh, yeah,
thing.
I totally noticed the difference.
And then we go back in here and we choose off.
Yeah.
Save. Export.
Yeah, it culled the back.
Yep. And see, there we go. So all the shaders that you've probably worked with in Unity have backface culling on by default.
Mm-hmm.
As a matter of fact, I think you ran into a problem with this when you were making your character transparent. Something's related to this problem in one of your shaders. And so you can specify in a shader whether it calls the back-facing polygons. And so what this means is if a polygon's facing away from you, like if I make a plane right now and rotate it so that we can actually see the thing. That's the wrong rotation. So you can see that the plane on this side, but if we rotate it the other way, you can't see it. If we were to apply this clip texture to it, whoops, you'll notice that all of a sudden now, if we rotate it, we have solved that problem, quote unquote. Now we can see it from both sides.
Because it's a back-facing
Yes.
culling.
Yeah.
Yeah.
Probably spending too much time on that, but
No,
I think it's
kind of
important
neat.
thing.
Actually, it's really important to know that
So-
because you will run into that problem, like making your own models, doing a whole bunch of different things if you're using transparency.
You could do the opposite too. Like maybe there might be a reason that you want to not render the front-facing polygons too, so we can actually do that.
Well, there's a lot of reasons why you wouldn't want to render the front-facing polygons.
And
like,
actually,
say
it's
you wanted
kind of
that
cool
as like a background or like the backside of a character or something like that. Like, you could do something along those lines. It's pretty neat stuff, actually.
So now we're only seeing the backside, which is
the inside
weird.
Of the
inside of the sphere, looking
so to
out.
speak.
The lighting's wrong on it.
Yeah. Well, but that's kind of
expected.
Yeah.
So I'm gonna switch this back to off. So let's see what other ones do we have. We actually have one this. Okay, there's a vertex modification graph. Let's see what this one does. Vertex. ABS, vertex normal, multiply, vertex position. Oh, that's clever.
Well, let's see it.
I wish I had thought of that. Using the normal. All
So
right.
what is it doing?
Vertex. This one is changing the actual rendering position of the vertices based on time fed into the sine function. This is what sine time is. It's a built-in helper function. And then multiplying it into the vertex normal, and then adding. So this is an offset, basically. This generates a number. This is an offset.
Mm-hmm.
And then this is the original position again, which is... so normally, if we don't do anything, what it's assuming is position equals position. That's all it does. It just basically feeds this directly into it. But what this is doing is this is creating a value to modify it, and it's based on the normal. And so let's see what it actually does. I hope it does something actually interesting. If it doesn't, we'll make something better. And we're going to create a new material. And we're going to actually put it on the sphere. It will look normal right now, and then we hit play. Okay, so this is actually just scaling out the normals. So this is not interesting. I thought they were doing something really cool, but they're
Well,
not.
I mean, it is kind of cool, actually. What it is doing is it's moving every vertex.
You could animate the scale, and you would get the exact same results.
Yeah.
Maybe here. Let's try it on a cube. Let's see what it looks like on a cube, just to see.
No, what
just
we
make
need
sure.
to do is just randomize all the different vertices.
Yeah, and that's easier said than done. But I'm going to show how to actually get some cool vertex effects. Definitely. Screw it. I'm just going to main camera. You can look at this way direction now. I don't care. Align with view. There you go. Okay, so it does do something different for the cube. That's cool.
Yeah, with the cube, it's actually really interesting what it's doing. That is very interesting. That is actually really, really cool.
Yes. Yeah.
So, see, that is not
Sphere is a special case that that makes it so
actually,
this is not
I
as
bet you
interesting.
almost anything is if you increase that number on the sphere, you'd see the sphere fall apart.
I don't think so.
Really? You don't?
No, but let's find out. Oh, wait. Okay, so what number are we going to increase?
I don't know. A number?
Alright, how about we just do function, another multiply here. Sorry, operation multiply. Alright, so I'm going to show you how to do some stuff in this editor right now. So we want an input. We're going to do a range property. We're going to call this amount.
Okay.
Whatever. It doesn't. I don't know what it's doing, so it's the amount. And let's just say that we can go from 1 to 100. And then we're going to create a property node called range, and it'll show up all red, and it'll be like, not going to develop property, and it turns this red too, so you know that it's probably related somewhere in there.
You think so?
So you click on this, and actually if you click on this, normally it's not red, but if you click on this first, you'll see, oh, it's red. And then you go to amount, and now this is actually a function. And we throw this into here, we throw the result of this multiply into here, and then we throw the result of this multiply into here. So this will increase the amount, or decrease it. We can go less than 1 as well, because I let it do that. So now, oh yeah, we have to actually compile the shader. Save.
And export.
Export. So
that did nothing.
It did nothing, but we have this amount shader. It actually did do something. It's not becoming small. So let's make it really big.
No, you're right.
Yeah.
Huh. How interesting.
I'm wondering if that's just because the cube is made wrong now, but maybe it's not.
No, because that was happening with the Toon shader for me, remember?
Yeah, that's more reason to believe. Oh, you made those cubes? Okay. Yeah. We just try capsule just for fun, just to see what that does.
Oh, how interesting!
See, I think there's something wrong with that cube. I think that those. I'll find out what actually is wrong with that cube later. I'm curious now.
Yeah, let's not worry about it.
All
right
right,
now,
so we've gone through a couple of the examples that are built in, and you guys can play around with those too. I'm not going to go through any more examples here. Let's actually make something. So I'm going to show you some of the things I was playing with, so first of all, let's make something that actually ripples in a more cool way than this. Let's work on the Vertex one first, because I think motion's kind of fun.
I agree.
So let's just gut this. Let's create a whole new graph. Yeah, confirm. And we're going to so the first thing that happens is settings is red. So the first thing you need is a shader name, and this is what will show up in the thing. So if you just say a name, it'll show up in this list under the name that you give it. You can also give it a name with a slash. I don't know which one. We're going to try both.
Okay.
And it should go into a submenu. So I'm going to create one called Pushy Pixels folder. I'm going to create a Pushy Pixels /shader test. I'll just call it shader. And we're going to we're just going to hit save. I'm going to call it PP shader. And we're going to go ahead and export as PP shader. Alright, and so we have this shader, and so if we go to like one of these, we should see, there it is, Pushy Pixels shader right there.
Wow.
And it does a whole lot of nothing. So it literally renders everything 100% black. So if you've been looking for some way to render something to be exactly black, no matter what the situation is, we've just done it for you. So you're welcome. All right, so
that actually can be helpful.
It can. What if you're making a shadow or something, like something for a 2D game or something, and you want just something to be completely black?
Yeah,
and there you go.
Certainly a thing that you could use.
So we're on the vertex output graph. So remember, there's 3 graphs. There's lighting, pixel, and vertex. So we're on vertex. So this is stuff relating to the points on the polygons on these objects.
Every
single one
point on a polygon.
Yeah. So so we have position, color, normal, and tangent. So color, first of all, I'm gonna let you know right now. This is not the color that you're thinking it is. This is actually vertex color. There is currently no shader built into Unity that uses vertex color at all. Phil, you've used a little OpenGL. You probably have made a vertex colored thing before.
Have I? It's been a while.
Remember those old triangles and stuff that had the cool shading between them? That was using vertex colors. So
yeah, those are cool.
So vertex coloring can be used for rendering. Typically,
those are cool.
You have so many other ways of doing color in a pixel pipeline. You'll almost never see vertex color used for color.
Yeah,
it's used for additional metadata that's not anything to do with color, that they just happen to pack into the color channel because we have no other place to put it in the polygon data. Yeah. So that's really what this usually is used for, is to pass in additional information.
Oh, interesting.
The normal is actually the normal off of the surface of the object. So like in the case of a sphere, because Unity actually does do this right, every single one of these vertices, their normal is pointed directly out from the center of the sphere. So like each of these points has a normal that's pointing out from the sphere, as if there was a line drawn from the dead center to the edge of the sphere and through the vertex.
And that's the normal.
If you don't do that, like something that's interesting is this sphere actually looks considerably more smooth here than these polygons would describe. Like if you look at this, we've got these wonderful smooth lines, even though you look at the polygons and you're like, oh, that's kind of blocky. If we did not set the normals, like if you would instead set the normals based on the center of each of these cubes, so each of these corners was set to the center, pointing out, what that would actually do is it would make it look more like a disco ball. If you want to make something look really blocky, you can actually change the normal information to do that.
Interesting.
But they don't do that because they want to have smooth-looking spheres. So I'm talking more about this background stuff, but maybe people will be interested. Maybe no one's turned off the show yet. So let's make something move, because that's what this show's all about. So
make it move.
We're going to take our position. So we're going to need to know our original position. So I'm going to grab that input first. So input is vertex. Okay, sorry. So there's world position, and there's screen position. Screen position is a 2D. World position is a 3D. So we want world position. Isn't there a vertex position? Actually, here, vertex.
That's a good question.
Vertex position. There we go. So this is the original position of the vertex.
Okay.
So we could do this, and it'll render exactly the same as it was before, because I think it seems to assume that if you don't put anything here. In the color section, it appears to assume black. So you're not always lucky on that. But so if we just did this does nothing. This is not interesting. So let's actually mess with it. So we're going to create a there's a function in here called, this is a really important one, called split. And there's a sister function that is equally important called assemble. And what these do is, so this position is just XYZ W position. Everyone knows what XYZ is. We're just going to ignore W. Just
why would we ignore W?
Follow my lead with W, because quite frankly I don't know anything about W.
Oh, I want to look it up.
If you want to know about W, talk to James. Man, James is the one to talk about W. He'll talk to W with you all day. It's additional information that's used when using quaternions. Really, it's for additional information. It's, if you've ever heard of imaginary numbers, it's kind of the same concept. Like, I still think imaginary number is such a bad name for a thing. Imaginary numbers are when you have square root of -1, right, is an imaginary number. And if you have 2 of those, it actually evaluates as something. But if you don't, it just is this thing that's sitting somewhere that we're just like, no, don't look behind the curtain. Same kind of thing with W. Like, W is important for when it's there.
But don't worry about it.
But don't worry about it. What we're going to do, actually, is we're just going to do this. We're just going to, ahead of time, just hook W into W.
Okay.
And then we won't have to deal with it. So we're going to take our position, we're going to split it into the XYZW components, and then we're going to reassemble the XYZW. So if we were to do this, it's exactly the same as what I did before that said it would do nothing. It just brings it in here. As a matter of fact, this has more overhead because it's splitting it out and then putting it back together. Why would you ever want to do that?
Essentially like taking it apart and putting it together again. Right?
Exactly. So what we're going to do is we're going to, somewhere between, so this is the question mark profit here. This is the question mark, this is the profit. And this is the input. So I guess underwear, question marks,
cooking
profit.
with Unity, question mark, profit.
Exactly. So, so I'm going to disconnect the X, Y, and the Z. And let's just perturb the, let's just do the Y value to start.
Okay.
So that we can see how this looks. So we're going to just hook the X into the X and the Z into the Z, and then we're going to do something into the Y. So let's just do a constant first so that you guys can see what's going on here. We're just going to add 1 to the Y. So we're going to do operation add 1.
Well, that's not going to be very exciting.
It's not, but it's illustrative. We'll do something exciting next. So this is going to be static. It's not going to be animated in any way.
No, it's not.
And actually, while we're here, I'm going to give this thing a lighting of some kind. So we're going to just do
Diffuse.
I'm going to go for Unity main color.
Oh, okay.
It's the same thing as a color property. This one just names it the way that Unity expects it to be named, which is useful. Like if you, for instance, if you do, so you could do just a texture 2D property and then name it something. But the real name for it is, if you want the main texture, is main text.
Okay.
And the reason that matters is if you've ever used the function, we've used it a couple times on the show where we get the main texture of the shader. If you don't use this one, if you don't name it main text exactly, Unity won't find it. Unity because it assumes this name. So that's the reason. If there is something that's already built into Unity that you use a lot, use these versions, not these versions. If you need like 37 colors, obviously there's not 37 color properties that Unity cares about. So So we're just going to do color. We're going to create a property color. We're going to hook it into color. We're going to throw that into the diffuse, and then we will have a happy shader that actually has some color to it. And actually in here you can set the defaults too. So if we expand this, it's going to default to white. I'm okay with that, but you can change that if you wanted to change that. So we're going to go to our PP shader. I'm going to create a new material that uses it, and we're going to throw it on our sphere. Whoops.
And you could already see what it did.
Yeah, you can already see what it did. So the sphere just jumped up in the air. And so that's not that exciting, but that's important to note. This sphere is not here. This, like, if we were to, if you click on it, here's the collider, and here's the sphere. Why is it up there? Well, it's because we're telling it to move 1 unit up exactly, which is why it's right on top of itself, because this is a 1 unit sphere.
Yep.
But it illustrates exactly what we're doing. So that's all we're doing. There's nothing magic about what we're going to do here.
Well,
so
it might be a little bit.
Oh, yeah, maybe. So now we want to actually make it animate. So we have an input. We have time that we can use as an input. And so let's put time in, and let's do our add again. And then just put the result into Y. Yep, now it's just going to animate. We're working up. So this will actually probably be pretty awful. We hit play, and it just starts moving up, and it will just move up forever and ever and ever.
Yeah, well.
As a matter of fact, we can't focus on it either, because if we choose to focus on this thing, it'll probably focus on where it actually is. So if I yeah, no, it's not there. It's going up.
There. It is actually there.
Well, it is actually there. It's just not rendering there. Yep. So there it goes off into space. So not very interesting
either. It's like a
either.
balloon.
So we could do something that doesn't go into space. We could do sine time or cosine time. I'm just going to do cosine time because it's at the top. They're really the same thing. They're the same function. They're just different starting points, basically. So we can save this one, and this one will actually very pleasantly move up and down. And you'll notice we haven't written any code, and this is all being done by the GPU. This is being done at the GPU level. So one of the nice things about shaders, and also one of the potentially dangerous things about shaders, is you are not using the CPU anymore. You're using the GPU for the most part.
Yeah.
And so that's really cool because it means that you're saving more time on the CPU, but it also means that if you have a bad GPU or if you're working on a mobile device, you may not have all of the features, and you may not have... It may not be as fast to do it on here.
You find that if you're iPhone developing through Unity, because there's like, hey, buddy, you might not be able to use these features very well.
Exactly.
Like, that's why they have the mobile option.
Yeah, exactly. Yeah, if you've noticed, if you've ever played around with the shader lists here, there's actually a mobile section. And there's a place, I'm going to link to it in the text. There's a place to download. This is really important. All of these shaders are just like these. They're these text format stuff. You won't be able to see the scene graph thing that the shader editor has, but you can at least see the code. And you can get the code for all these. It doesn't come with Unity, but it is open source and it is available on Unity's website. I'll put the link in. So if you want to know how they did the built-in shaders, that information is out there. Mm-hmm. It's also really useful. You can look at the mobile shaders and find out why they're mobile. Like, as a matter of fact, you can actually find that out really without even looking at them, because if you go to, like, the big difference, if you go to a diffuse shader, you have a color and the texture. And this color is actually being blended with the texture. The mobile version of this, of Diffuse, just has the texture. Mm-hmm. They're saving you the blend operation. Blend operations can be expensive. So that's saving a add per pixel on the texture right there. So that's one of the differences. There's probably a few different, like, cut corners and places and stuff. But
yeah.
But in general, they're a little bit faster, but not necessarily as many features. Sometimes they look identical, just different features, and sometimes they look just a little bit different.
Yep.
So yeah, add this cosine time. Still not that interesting because it's doing the same thing for every vertex. So let's actually make it so it's different for every vertex. So what we're going to do is we're going to get rid of our cosine time, which is our helper function there, and we're actually going to do this ourselves. We're going to bring out the cosine.
Cosine.
We're going to feed it in. We're going to grab a add here, operation add. And we're going to feed in the the y vertex position. We're going to add it to the time, and then we're going to take that whole thing and do the cosine of it. And then we're going to add it to the original y.
Do we want that connection between y and... Oh, yeah, we do.
Yeah, we absolutely want everything that's connected right now. So if we go save, and we go export, this will actually give us our first interesting result. So we hit play, and it's not as interesting as I thought it was going to be, is it?
Nope.
Did I not export that hard enough?
I don't know.
Why do I have a texture? Did I actually add it? Well, yeah, I don't think I exported that hard enough. Wait, what the heck? Oh, I changed the shader to diffuse. That's the problem.
That would explain a lot, wouldn't it?
I was like, why is there a texture in there? I swear that we didn't do that. All right, so here we go. We hit play. And there we go. We have something interesting looking all of a sudden.
That's very strange.
Yeah, it is a bit strange, isn't it? So what this is doing is based on the Y position. It's not, I don't think it's world position based, so I think if we move this sphere around, it will still do the same thing no matter what. Yeah, it's still doing the same thing. It's just in a different position now.
It just looks floppy.
Yeah, it looks floppy. We weren't caring too much about what we were doing. We were just basically, so if the Y position is different, it'll be in a slightly different position, and the farther away it is, the more the difference will be.
Yeah.
And so, so we have something interesting going in there. So, like, if we let's actually do this for every single one of these inputs, with the exception of W. We don't like W. I'm just going to duplicate this.
I like W.
Duplicate this again. And so this one we just throw in X and X. Enter the result into X, and actually, for sake of not having the wires too crossed, I'm going to have this actually be X, Y, and Z in that order, so that we don't confuse ourselves too much.
Too late.
Oh, you're already confused?
No, not really. I just wanted to say that.
Fair enough. I opened myself up to it. Alright, so now we have this. export. So we hit play, and now we have this really weird effect. Let's actually try this on all of our little dudes here. Let's put this on the cube, and let's put this on the capsule. So already you may actually have thought of something that you could use this for. If you wanted to create the effect without Unity Pro of being underwater, if we were to lower the values a little bit that this thing is feeding in, it will look very much like a underwater scene.
Yeah.
It has that kind of ebb and flow to it. Let's actually do that. Let's actually make this a little bit more useful. So we don't want to add the whole thing to it. We want to add a amount to it. So what we're going to do is we're going to add a... we could do this as 3 separate things. I'm just going to do it as 1 for now. But you could do this individually per type. I'll leave that as homework. So we're going to just put in a... we just need a range. So I'm just going to call this wave amount. We're going to call this waves, I guess. Okay, so I can't type right now. If that happens, don't panic. Just close it. Open up Strumpy Shader Editor, and then spend a half a year figuring out how to put that on the other thing, whatever. Waves. I'm not going to bother putting this in a separate...
Vertex.
Okay, so we go back to the vertex graph. We add a input, properties, float node. Sorry, that actually won't work. We need properties range. It has to be the same type as this one. You'll know real quick because you'll go in this list and it'll say there'll be nothing in this list. So,
yeah.
So waves 0, 1. We actually want that range to be a little bit better than that. We want to make it so we can go. Let's do just a 10. Let's not go crazy, and let's default it to 1. So we're going to take our multiply operation, and we're going to feed in. So we're going to need 3 of these. Duplicate, duplicate. And we feed in our range as to one of them, and then each of these will feed into the other. And oh my god, it's looking messy. It'll look a little better once we hook this up. Maybe not. Z, Y.
A little bit better, actually,
X. Yeah. You can move these around. It renders them in real time. I'm not going to worry too much about the organization because it doesn't really matter. But try and keep it organized at least to your own.
It's just a visualized flow.
Yeah, exactly. So we're going to save, export, and we're going to switch over to... Oh, I'm going to have to figure this out. Oh yeah, that's right. We're just doing this. F9, drag that in. There we go. All right, so now if we hit play, we're still in this situation, but we can go into the sphere. And this actually affects it to everything, I think.
It
but,
should. Yeah.
Oh yeah, the other ones don't have it right now. So we can set this amount to very low. Oh, this is...
That's interesting.
I see. I'm doing this in the wrong place. Yeah, this is actually not a good place to put this.
Oh no.
Don't worry, we'll get this hooked up. We actually want to put it before we add in the original value. So that way when we zero it out, there will be no effect, as opposed to
Correct.
it zeroing the whole thing to nothing. So operation, multiply, and I'm just going to make 1. I'm going to hit duplicate, duplicate. We're hooking it up pretty much exactly the same way, just instead of using the final result, we use the intermediate result here. We hook this into here, here, and here, and then we hook these back up.
To X, Y, and Z, but not
X, Y, and
W.
Z, but not W. We just are passing W through. W is probably
It's a
1
4th dimensional number.
in all of these. It's kind of, yeah, basically it is a 4th dimensional number. All right, so now we're at this. No, we didn't compile it.
No, we did not.
Save. Export. There we go. Hit play. So now if we have nothing, we have nothing. If we move it up a little bit, it waves a little bit. And we can move it
There
a
you
lot
are.
where it just
Like,
goes all over the place. But
very
yeah, if we do
slight
very
movement.
slight, we get this nice kind of wavy, dreamlike movement on it.
That's kind of cool.
So, now you mentioned just random. Like, random would be great, but, and you could probably do it in a shader easier if you were writing the code, the CG code for it. But right now, there's nothing, like, there's not a Perlin noise function. There's not any really useful randomized function. So if you want to do random, you're going to have to write your own random for it. The other option you can do is, of course, you can have you could have one of these things as an option in it, and then do a script that changes that parameter for the material.
Oh, okay.
So you could so if you want to do a 50-50, CPU does some things, GPU does others, you can work that. So in Unity at least. Actually, you can do that probably on any project, but in Unity it makes it easy to do that.
This is kind of neat.
So we have the movement there. Let's actually play around with the color. So we've got just a base color in here. So let's actually make something interesting. So first off, I want to show how to do a texture, just so that people know. So we're going to do a texture 2D actually, we're going to do the Unity main texture property. And you can reorganize these with these little badly labeled up and down arrows. But so I usually like to have color and then main texture, just like the Unity ones do. So the main texture, if you just put this in here and then you do properties, sampler 2D. This is actually what we can hook into our main texture.
Okay.
And so we can function. What's the one that actually does this? So there's a text 2D function here, which takes a sampler and the UV. You just can connect those directly over. And then this output will give you the color. So now we want this to actually add to the initial color. So the way that you do this is if you just add them together, it's not perfect because you can have over 1.0. And that's technically not meaningful. It probably still works, but it means that you'll be oversaturating your range. So the way that you can solve that is just by simply doing a multiply first. And we're going to add a float for const. We're going to set it to 0.5. We're going to need 2 of these. So we multiply this one by 0.5. This one by 0.5. I could probably have 2.5s there so that we don't have the lines going over everything, but I'm not going to because we don't need them.
It doesn't matter.
And then we do a operation add. So this will do a 50-50 blend between whatever color is put in and the value. Is that what we want? Yeah, I think that's what we want.
I think that's right.
I think this is pretty normal. So we put the results in there, and we throw the results into Diffuse. So
and there's no alpha channel right now.
There's no alpha channel right now. And actually, I'm going to go over alpha briefly, I think, because there's some important stuff to talk about. I'm already kind of at an hour here, but
I think we should honestly have another episode of this. Okay.
All right. Well, if that's the case, then let's... Do you think this does deserve a second episode?
Yeah, there's a lot of stuff to do with this.
All right, let's do that. So we're going to do one more shader episode after this one.
I think that's not a bad idea myself.
So now we have this this texture here.
Start that up again real quick.
Sure thing.
That's kind of cool.
Yeah.
I like that.
So you'll notice that if I was to change this to, like, say, what is it called? Diffuse shader, it should look exactly... Okay, so it looks exactly the same color-wise. So that means we did it right.
Yeah.
So, what is it?
That one?
Yeah.
Now you could also put in an image.
So now we can actually put in an image in, and it should work. I'm just going to grab... Yeah, we'll just do this. Something I made so I don't have to worry about copyright. So now we have this thing in there.
If you notice, it's blended between the diffuse
it's blended between the diffuse and the other. So if you want it to be just that, I think it's actually at the...
You'd have to make like a little slider or something,
yeah.
Right?
Do we not have a light? No, we have a light.
Do we have a light?
I'm wondering if I did that right. Anyway, that's one way that you can blend them at least. All right, let's go over alpha real quick. So let's make it, let's actually look at that edge thing. So I'm going to save this, and we're going to load that rim light. And I'm going to see if I can get away with this. I'm just going to take all of this stuff that they're doing for Emission. I'm going to hit Command-C. And if we're lucky, I'll be able to load our PP shader and paste it in. Oh, we were lucky. We were so lucky that I did it 3 times. Literally. More than 3 times. Actually, I'm just going to undo all of this. No, I'm not. Oh god, I'm undoing things that are in the Unity editor. There we go.
Oh, that's terrifying.
Alright, so undo doesn't work, but command paste. Okay, I'm just going to delete these, and we're going to do this again real quick. I duplicated it again! Oh, I got rid of our 0.5. Constant, float, 0.5, no, 0.5. Bam, and bam.
Alright.
So, we're back to where we started from. I'm going to hit save again. I guess I could have just done that. We're going to go back to our rim lighting. Not ours, but Strumpy's rim lighting shader, which is very cool. Command copy. I'm going to trust it this time. We're going to load PB shader. Command paste. Wait for it. There we go. So, color not configured. So we need color that needs to be an input. So we already have this one, so I'm just going to throw it in here. We're going to delete that. And range, this is a 0.1 to 3, so I'm just going to do the same thing. Add new input, range,
So 0 to 3, you said?
Yeah, edge alpha is what I'm going to call it. Or I would if I could type. Edge, okay. Click. Yep, okay, we're closing it. Open it again. This has become routine now. Inputs, edge alpha. And we're going to do 0.1, 2, 3. Let's do that as the range. And so now we're going to use this for our alpha. And at first this is probably not going to do anything. So and we need to actually configure this to be our new range, edge alpha. So we're going to hit File, Save, File. I guess I have to export as again, so just remember what your shader's called if you're going to be exporting it.
Save often.
Yep, save often. And when you're experimenting, save a bunch of different shaders, like play around with it. So we have this edge alpha thing here, and if we change it, nothing happens. So that's not very exciting. And yet I plugged it into the alpha, and you'd think that that would do something, right? So the problem here is... Oh wait, we don't need to add the color in here. Let's just put the result in here. We're still going to not see anything. I'm just going to do this as a test. Maybe you might think that was the problem, but it's not. Just trying to confuse people as far as I can. So there we go. It actually might do... No, it doesn't do anything. Yeah, it's doing a whole lot of nothing. So that's not very exciting. So here's why. If you go to settings, there's this Q settings thing. Remember how I was talking about how Unity does this for you? Well, if you're making your own shaders, you have to tell Unity to do it for you. Yeah. So the render type here is going to be transparent, and the render Q is going to be transparent. And then the blending settings we also have to change. I think if we just do decal blend is what we want.
Okay.
The other way you can do it is if you go to custom. This is the I think it's the equivalent of doing source alpha and 1 minus source alpha, which this is a standard. If you were expecting an alpha blend to blend like you've ever seen an alpha blend, this is it. Source alpha, 1 minus source alpha.
Okay.
I think decal blend does the exact same thing though, so we're going to try that one. So we're going to go save and export. And there we go. Now we have an alpha transparency. You'll see that we have this really cool looking bubble.
Yeah, it is a bubble.
And you can change how much is transparent on it. and it's real transparency. Like if I move this thing over, so it's over our other geometry here. Oops, that's not moving. You can see that it's actually alpha blending as we would want it to. And it looks really cool. And this is actually just doing what the rim lighting was doing, so you can kind of see how the rim lighting worked here. And it's just applying that value to the alpha channel rather than to the color channel. And so now we have something that looks like a bubble. And it's, again, it's just using the view direction to do this. So, how do I get to the right? So, yeah, no matter what angle the camera is, the center is transparent. Anyway.
That's pretty cool.
I think I'm going to just leave it at that for right now.
Yeah, I think we should do another one
of these. Yeah, we'll do another one of these, unless I get a lot of complaints or something. So, thank you for joining us tonight. If you need to contact me for any questions, if you want to complain that we're doing a second episode on Strumpy Shader Editor, email me at pushypixels@pushypixels.com. You can also tweet me at Drakfire, at Drakfire.
Yeah, if you want to email me, like you're like, hey, I want to send you an email. I'll be like, okay. So you can email me at philip@protosoftworks.com. Or you can follow me on Twitter if you feel really adventurous. It's at magmalemur. I like to tweet. Tweeting's fun. Twitter.
Why do you do that?
I don't know.
Okay.
I'm weird.
Well, anyway, because he says Twitter a lot, you should buy Automation.
And you should buy Proton Pulse.
Even though I don't say Twitter a lot. Yeah.
Yeah.
Buy both those things.
Buy them.
Yeah. And we know that you don't listen. It's because we've looked at our sales. You guys aren't buying anything. So
that may not be true. But I bet a few people bought something.
Anyway,
but I really appreciate it.
Yes, we both totally appreciate it. We promise we're not trying to steal your money away from you. We're just trying to live. So,
do like to live.
You guys have a great week, and I'll catch you next week on Monday with some more shader magic.
Have a super happy week.